So 16.2 Application of Integration in Kinematics. In the last session, we learned that when a particle moves in straight line, where the displacement from a fixed point O on the straight line is s, then the v is ds dt. Then the a is dv dt, that is the second derivative of s. Conversely, if a particle moves in a straight line where the acceleration of the particle is a, then we have the v equal to integrate of at, and the s is integrate of the v dt. So actually we have the s and the v and the a. So the relationship between these two, okay, will be something like this. We have the v is ds dt, and the a is dv dt. Then the v is integrate of a dt, and the s is the integrate of v dt. Okay, so we look at the work example number 5. A particle move in a straight line past a fixed point O with velocity 8. So that means when the time equal to 0, okay, so when the time equal to 0, the displacement equal to 0, but the velocity is 8. So the acceleration is this, a equal to 2t plus 1. So we have the a equal to 2t plus 1, then the v is integrate of a dt, then it's the integrate of 2t plus 1 dt, then it's t squared plus 2, t squared plus t plus c. Okay, so when time equal to 0, then the v is 8, then we substitute 0, 0, then we will get the c equal to 8. So the v is t squared plus t plus 8. So a, when t equal to 3, the velocity will be 3 squared plus 3 plus 8, 20, okay, meter per second. So next, find the displacement, okay, from O when t equal to 3. Okay, so we know that the s is integrate of v dt. So integrate of t squared plus t plus 8 dt. T power 3 over 3 plus t power 2 over 2 plus 8t plus c. T equal to 0, s equal to 0, implies the c equal to 0. So the s equal to t power 3 over 3 plus t power 2 over 2 plus 8t. So when the t equal to 3, so t equal to 3, the s equal to 3 cube over 3 plus 3 square over 2 plus 8 3. So we have 9 plus 9 over 2 plus 24, 33, and then 37.5. Okay, so we have this one is the x power 3 over 3 plus x squared over 2 plus 8x. When t equals 3, then it is 37.5. Yes. Okay. Work example number 6. A particle moving in a straight line passes through the fixed point O. Velocity is this. Find the acceleration when t equal to this. So we know that the a is dv dt. So the a will be 18e3t plus 2. So t equal to 1, a equal to 18e31 plus 2. So 18e plus 2. Okay. So 18e plus 2, 18e cube plus 2, 363. Okay. This one is cube. 364, around 364 meter. Okay, meter per second square. B, find the expression for the displacement for the particle from O. So pass through fixed point O, that means when time equals to 0, the S equal to 0. So we have the V, the S is integrate V dt. So we have the integrate 6e3t plus 2t dt. Then this one will become e3t. 6 divided by 3 is 2. T squared divided by 2 then plus c. So t equal to 0, s equal to 0. So we have the 0 equal to 2e0 plus 0 square plus c. So 2e0 is actually 2 plus c equal to 0. So the c equal to -2. Therefore, the s is 2e3t plus t squared minus 2. Okay, so we must be careful here. When we have the e here, t00, the c not necessarily 0. Okay, so this one e power 0 is equal to 1. We must know that the e power 0 is equal to 1. Okay, e power 0 is equal to 1. So C, find the total distance traveled by the particle in the first 2 seconds of its motion. So we must check whether it stopped or not somewhere before this one. So when v equal to 0, then we have the 0 equal to 6e3t plus 2t. No, 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 no. Okay. No, just we just assume they don't because that one is we can't solve. We have the 6 e to the power of 3x plus 2x alpha equals 0. Shift solve 0. Uh, shift solve, yeah, 0 only. Okay, shift. So this one alpha equals 0. No, 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 no. 6 e 3x plus 2x alpha equals 0. Shift solve. So actually they don't turn, they don't stop and turn here. Okay, so we know that time equal to 0, s equal to 0, time equal to 2, then the s is equal to 2e32 plus 2 square minus 2. So we have the 2e3x plus x squared minus 2. Calculate when x equal to 2, then we have this. Okay, so the total distance travel equal to 809 meters. We can also do it the other way. Okay, method 2 for this one. So the s is integration for the v, that is the 6e3x plus 2x from 0 to 2. Okay, we'll also get the same answer. Okay, look at example 7. A particle start from brass Okay, start from rest. So time equal to 0, velocity equal to 0, leaving a point O. So the uh, S also 0. So this is the V. Find the range of value of the velocity. Okay. Mm, range 4 plus 8 cos 2t. Okay. We know that cos x is between -1 and 1. So the cos 2t will between -1 and 1 as well. If we have 8 cos 2t, then it will become between -8 and 8. So we multiply 8 here. So after that we plus 4. Then we have the -4, 4 plus 8 cos 2t. Well, so the v is between -4 and 4. Okay, so this is part A. B, we need to find the range of value of acceleration. So before we find the range of acceleration, we must find the equation of the acceleration. Then we have the -16 sine 2t. So differentiate the 2t is 2. Differentiate cos will be negative sine. Okay, so we know that the sine x is between -1 and 1. Sine 2t also between -1 and 1. If we have a negative sine 2t, it's also -1 and 1. Okay, because when we multiply with -1, then it will become 1 greater than or equal to sine negative sine 2t, negative sine 2t greater than or equal to -1. So we rewrite will become this. So we have the -16 sine 2t. It will become between -16 and 16. So therefore, the A is between -16 and 16. We can use the decimals to demonstrate this one. Okay, so we have the sine 2x will be this graph. Okay, then we have the negative sine 2x look like this, and we have the -16 sine 2x with this. So the highest is 1 and the lowest is -1. Okay, so if we multiply with the 16, then the highest is 16 and -16. Okay, so see, at first this is the graph of sine 2x. So 1 -1. So we multiply with negative, then the 1 become -1. This is how the graph look like. And then multiply with 16, then this will be the graph. Okay. Okay. And for this one, the v is 4 plus cos 2t. 4 plus 4 plus cos 2t. 4 plus 8 cos 2x. Okay. So first we have the 2 cos 2x. First we have the cos 2x. Then after that we have the 8 cos 8 cos 2x. Then, so we can see that this one, okay, at first we have the cos 2x is between 1 and -1. Multiply with 8, then it's between 8 and -8. Plus 4, that means this one moved upward 4 units, then 12 and -4. Okay. Um, then next, we need to find the value of t when the particle first come to instantaneous at rest. So that is the velocity equal to 0. So we need to find the value of velocity equal to 0. Okay, so this is the v. So we have the v equal to 0. So 4 plus 8 cos 2t equal to 0. 8 cos 2t equal to -4. Cos 2t equal to negative half. -4 over 8. That is the negative half. Then the basic angle will be the arc cos 1 over 2, that is 60 degree. So arc cos 1 over 2, that is 60 degree. And then we know that the all sine teacher crazy. So cos negative is this 2. So the 2t will be 120 and then 240. Okay, so this is theta. This is 180 minus theta. 180 plus theta. 360 minus theta. So the 180 minus 60 is 120. And then we have the 180 plus 60, that is the 240. So the t is 60 degree or 1200 degree. Then therefore the t is okay. You can see that the t is in terms of pi. If the question didn't mention its degree or radian, then we must change to radian. So this is pi over 3 rate. Okay, so this is pi over 3 rate. Okay, find the distance traveled during the time interval from 0 to pi over 2. Okay, so uh, just now we have this is the cos. Okay, then pi over 2 is here. Then pi over 3 is here. Yes, this is correct. Okay, so we can have something like this. Uh, the x is from -2 to pi over 2, 2 to 2. So this is how the graph look like. This and this. Yeah. Okay. We know that it changed direction when it is pi over 3. So the distance traveled in the from between 0 and pi over 2. Okay, we have two methods to solve it. Okay, the first method is we integrate this one. Okay, uh, we have this one is uh, this is d, 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 d. Okay, so we have this one. Okay. Um, the S is integrate V dt, integrate 4 plus 8 cos 2t dt equal to 4t plus 4 sine 2t divided by 2, 8 divided by 2. Okay, cos, integrate of cos becomes sine. Okay, plus c. You know that t equals 0, s equal to 0. Okay, sine 0 is 0. Sine 0 is 0. Okay, then we have the c equal to 0. So the s equal to 4t plus 4 sine 2t. So t equal to pi over 3, okay, which is 60 degree. Okay, that is 60 degree. Then the s is 4t, 4 pi over 3 plus 4 sine 2 pi over 3. Then we have the 4 pi over 3 plus this one is the 4 sine 120 2 square 3 plus 4 pi divided 3 7.65 7.65. When t equal to pi over 2, that is 90 degree, s equal to 4 pi over 2 plus 4 sine 2 pi over 2. 2 pi plus this one, okay, 4 sine 180 lor. 90 times 280, 0. So 2 pi on it. Okay, 2 pi, that is 6.28. 6.28. So the what happened here is when time equal to 0, okay, s at 0, 7.65, and then it go back here, 6.28. So the total distance is equal to 7.65 plus the 7.65 minus 6.28. Okay, over here is 7.65 minus 6.28. So we have the 7.65 times 2 minus 6.28, that is the 9.02 meter. Actually, for this question, we have something easier if you are good in the integration. So for this part is integrate of the 4 plus, so 4, wait, 4 plus 8 cos 2x from 0 until pi over 3. Pi over 3. But I must change uh, the calculator to degree. Angle unit is the radian, change to radian. Yeah. So this is the first area. Then the second area is the integration of this one from pi over 3 until pi over 2. Pi over 3 until pi over 2. We modulate it. Okay, so this is the second area. So just now this one 7.65 minus 6.28, 7.65 minus 6.28 is actually 1.37. So this 1.37. So the total distance traveled will be 7.65 plus modulus negative 1.37. So we have the 7.65 plus 1.37, then it is 9.02. 9.02 meters. So normally I will use the second method to check the answer lah, because to find the total distance here, it's easier to write it this way lah. To write it using the uh, using this one, using the displacement here. Okay, so this is the total distance.